Okay, good evening, everyone. Thank you very much for joining us live today on this nice LinkedIn Live session on IoT New Frontiers, New Threats. It's a very fascinating technology. It helps in connecting various devices together to ease the operation and sharing of data amongst themselves, amongst each other. There are various smart devices such as sensors, smartphones, and wearables which collect necessary data from the devices, which are further utilized to enhance customer experience. The increasing need for data analysis and integration of analytics is expected to actually propel the utilization of IoT and IoT devices. And that's the reason why uh, this whole market is expected to reach an astronomical value of some 1.6 trillion US dollars by 2026. Currently, it is at around 762 billion. I mean, all of this is very astronomical for people like us. Um, with the advances in wireless networking, such as 5G, the emergence of advanced data analytics technologies, a reduction in the cost of connected devices, an increase in cloud adoption. All of these factors are actually contributing this to the growth of this market. Um, Another factor is that the growing adoption of IoT technologies across end user industries, which includes manufacturing, which includes automotives, healthcare, power, and many others, is nothing but crazy. I mean, every industry is actually moving towards adoption of IoT. With the traditional sectors aiming at at bettering their customer experience, IoT is surely a factor in that will fuel the next industrial revolution of intelligent connectivity. So therefore, we associate IoT very closely with Industry 4.0, and both of them are at the center of new technological approaches for development, production, and management of the entire logistics chain, supply chain, otherwise known as smart factory automation. This is a massive shift which is happening. Um, while the technology growth and its adoption is promising, there is a major flip side to it. And the flip side is the security of IoT devices and sensors. IoT is a wonderful technology in many ways, as I explained in my initial few paragraphs, which I spoke about. But unfortunately, technology has not matured yet and is not entirely safe. You would recall the Mirai attacks when that happened for the first time in 2016, and people realized that any device connected to the internet is a potential ally for an army of bots. But that was only the beginning. For now, we can very with a great deal of conviction we can say that IoT and security are still not found on the same page in the same place. There are still many risks and security challenges of IoT that the industry is witnessing. For example, if I can tell some of those challenges, the lack of compliance on the part of IoT manufacturers, the lack of user knowledge and awareness of the users of IoT, IoT security problems in the device update management, lack of physical hardening, botnet attacks, industry espionage and eavesdropping, major concern, hijacking of IoT devices. I mean, these devices are so cheap that the manufacturers have actually not thought of, embedding security into this. I mean, this was an afterthought, I guess. There are issues of data integrity of IoT security. Rogue IoT devices are dime a dozen. There's a crypto mining which is happening through IoT bots. So there's a lot which needs to be covered, and I'm glad that we have with us one of the top industry experts on this subject. Let me welcome Aseem Jakhar, who is the co-founder and director of R&D at Payatu Labs, which is a research-powered cybersecurity services company specialized in IoT, embedded cloud, mobile, and infrastructure security. He's also the founder of Null, which is an open security community, registered not-for-profit organization and one of the largest security communities in Asia. We are very proud of this community. You must have, I mean, there's no need to introduce NullCon. NullCon is an iconic conference in itself. He also organizes Hardware IO, which is another great brand to reckon with. At Payatu, he heads the product development for CloudFuzz and IoT Auditor, and spends a lot of time trying to solve the IoT security problem. So I think I have introduced enough, Aseem. I would like you to take over from here. Welcome for this LinkedIn Live session.
Thank you, Rahul. Am I audible?
Yes, you are. Please go on.
All right. So first of all, thanks, Rahul. Thanks for giving me the opportunity to come and speak with your audience. I'll be basically talking about IoT from a security perspective, and what are the challenges that it brings with itself. So before that, I think Rahul has already covered most of the things. Just a couple of things that I write open source security software as well during my free time. So what I'm going to be talking about today is I'm going to take you through the journey of an information security professional from the 20th century to 21st century to now. What are the challenges? And then I'm going to end with very basic actionable items and steps which the stakeholders can take back to their work and start implementing it. So let's start with the 20th century. There was a young and a dynamic professional, and he was tasked with securing the infrastructure of of his enterprise. Now, back in those days, securing the infrastructure typically meant that your IT infrastructure was typically comprised of desktops, laptops, server machines, routing equipment, and so on. So it was, hackers and researchers were finding out new vulnerabilities in server software, client-based software. So he had he had a fair share of nightmares back then, but eventually over time we started to figure out what was what was the modus operandi of the adversaries and what are the things that they would typically go after. So during the end of 20th century, we could say that the industry had come to a stage from an IT infrastructure or software perspective where a lot of things had become common. There were a lot of best practices, guidelines, compliance available in terms of securing your assets. So we had pretty much a lot of information available by the end of 20th century. Now, coming to 21st century, the same professional, well, now not so young, was tasked with managing or owning the infrastructure of the enterprise, which obviously included security as well. So from that perspective, you had the typical IT infrastructure where you had laptops, client desktop machines, routing equipment, servers, and whatnot. So these were almost a solved problem. But then some innovation happened, and people started getting these interesting and magical devices, these touch devices, which they called smartphones, to their offices. So that gave a bit of a headache to our friend here. And so then the industry also came up with the guidelines and policies on bring your own device. And so, but the idea here was that in addition to the traditional IT infrastructure, now he had to manage devices which he did not have much control over. So once the professional professional, or rather I should call CISO here, started defining policies for this, the organization or the top management had their own ideas, where they looked at as this new technology where they could offload a lot of their infrastructure or assets uh, onto something called as the cloud. So they basically did not need to manage the hardware itself. They did not need to manage the security of the hardware and the infrastructure, and then you could offload everything onto the cloud. So this gave bit of a headache to our friend here again, because he had to now go ahead and define policies in terms of how do I secure something that is not in my direct control, because what is happening inside the cloud, nobody has a clear view over. But then over time, industry came up with regulations, guidelines, best practices. So our friend here started to incorporate those into the process. And while he was doing this, the smart engineers in the organizations figured that this cloud technology is really, really cool. Why don't we offload some of our automation and work on to the cloud? So thereby, making things very easy for us. We don't have to request for hardware, and we don't have to run. There'll be no limitations on the number of devices that we need. And then that gave birth to something called as the shadow IT, which gave further headaches to our friend here. So then again, he had to go ahead and define policies and whatnot. And we are still, I think, facing a lot of challenges in terms of shadow IT as well. So you see, the infrastructure over time has become so complex, and it's not centralized anymore. There are people carrying devices. There are people who have devices inside them. We'll come to that later. And then you have your assets on the cloud. Then you have your assets on the cloud which you're not aware of. Fast forward to recent couple of years, your infrastructure is not about only these things, and everything now is being automated with these small devices called IoT, or sensor, or cyber physical system. Now every industry or every infra that you look has a lot of these devices connected within the infrastructure, or part of the infrastructure. And going forward, everything is going to automate. This is not going to stop here, and it's going to automate to such an extent that even humans will not be spared. And we've already seen pacemakers. They're not something which is new. And there's a lot of innovation going in the medical industry in terms of augmented limbs and organs, and so on and so forth. I think everyone is already also aware of Elon Musk's the Neuralink project as well. So it is going to definitely change the way we look at infrastructure itself. So obviously, with time, the nightmares have also upgraded themselves. So let's look at so if you look at the industry, we are not there yet. So when I talk about the industry, I'm talking about the tech and the cybersecurity industry, because there are a lot of things which are available, but then because of this automation, there are a lot of things which we still are struggling with, and more specifically comes down to the hardware, the radio communication, and the sensors. So what exactly is the challenge here? So let's start with the first part, and defining the IoT ecosystem. So if you look at IoT, it's not, when you look at an IoT device, it's not a single product or a single device. It's a combination of different technologies. So if you look at just the attack surface for one typical product, that's huge, because that contains your cloud, that contains the hardware, that contains the mobile application, that contains the radio communication that it is doing. Now multiply that with the number of devices that you would deploy in your infrastructure: thermostats, Alexa, TVs, phones, conferencing phones, and building management systems, HVAC systems, and so on. And we are already seeing malware attacks on these IoT devices itself, and there are plenty of examples of network breaches because of these devices. The other problem is that from the manufacturer and the asset owner perspective, there is a huge supply chain of components, both hardware and software, when we talk about IoT. And as a manufacturer of an IoT product, you do not have visibility into the security of those third-party components. So be it the components coming from a vendor, or be it open source component. So that is a challenge that you have to solve. Security testing of the IoT itself is a huge task. I mean, just testing one product is like testing the whole ecosystem, because you have to test again, you have to test the whole stack of the product itself, and then you can multiply that with the infrastructure. Now, there are certain regulations and compliance which are coming up, and which are going to be very, very stringent in the coming years. And we are already seeing IoT specific guidelines and compliance that are coming up, laws that are coming up, and certain other compliances like GDPR, and then domain specific compliances like HIPAA for medical, IEC 62443 for industrial IoT, PCI for payment-based devices, and so on. So this itself is a huge challenge, both for the manufacturers as well as the infrastructure, or the users of those products. So at a very bare minimum, if you look at what are the problems that we have to solve as of now, and these basically will boil down to these three, and these are the new age attacks that we have been seeing in the past decade, and will continue to increase. So hardware has, because hardware is getting cheaper day by day, a lot of companies are coming up with innovative, you just buy a development board, create a prototype, and then go ahead and start marketing or selling the product. The issue here is that these product companies are not hardware designing companies, and so they would typically trust the hardware from a security perspective. Now, if there are issues in the hardware layer, then it does not matter how much security you put in the on the software stack. It's eventually pointless. The next is radio, because some of these devices, or most of these devices in the future, are going to be deployed in remote areas as well, which means they would need long battery life. The way to communicate would be efficient radio protocols, which make sure that the product can sustain on battery for years to come. So these new radio protocols like Zigbee, Z-Wave, LoRaWAN, these are coming into play as of now, and they have a set of problems of their own. And to add on top of that, companies are coming up with the proprietary radio protocols. And I think the past has taught us that there's no such thing as security by obscurity. So if you have a custom communication protocol, eventually researchers will reverse engineer and figure out security flaws in the communication. The third one is the sensors themselves. Attackers would typically find ways to manipulate the sensor data, so that the users are getting wrong values in terms of what exactly is happening in the physical world where the sensor or an actuator is deployed, versus what the user sees. And we have one of the biggest example in the early days was Stuxnet, right, where the users were seeing the different values, and the centrifuges were actually moving faster than what they were seeing. So and then there have been tremendous there are a lot of examples on the internet that you can search, where typically you would try to bypass the transducer. So transducer is either a sensor or an actuator, which means basically you're attacking the business logic of the IoT product. So who is responsible at the end of the day? If you are the owner of the enterprise infrastructure, enterprise or whatever infrastructure, your neck is obviously on the line. But not just the infrastructure owner, because you have deployed, you have purchased some products and deployed it in your infrastructure. It's also the responsibility of the product owners to make sure that the products are secure. Because if eventually, if there are vulnerabilities in the products, you would definitely be either fined or liable for a lawsuit, or you will have to do a product recall. And product recalls are the worst nightmare for any manufacturer. So now what? I mean, I've scared you enough. I don't want to scare you more. So let's end the presentation on a good note, in terms of I have listed down some very basic things which you should start implementing within your organization starting today itself, because once you get a hang of what exactly does your infrastructure include, you will be in a better position to say with confidence how secure your infrastructure or your product is. So as an exercise, if you want to do it, just try and identify the IoT assets that you have within your infrastructure, and I'm pretty sure you'll be surprised with the results. So as a first thing, I think one of the things that you need to identify is what is it that you own and what is it that you don't own. Both things are going to help you. The first one is going to help you identify what assets come under your purview. And the second one is going to tell you what are the devices which are present in your infrastructure, which do not belong to the organization. So these could be typically either rogue devices or shadow devices that the users, the employees might have. So the easiest way is to look at the procurement records in terms of what kind of equipment is procured for your facility. If that is part of your responsibility. And the next stage is, once you have an idea of, okay, so we have Samsung or Sony TVs deployed everywhere, and these are connected to the infrastructure. The next is to perform an active and passive network discovery for these devices, not the traditional network discovery where you're going to discover PCs, because I'm pretty sure you already have a strategy and tools available which would give you a list of all the assets through active and passive network discovery as well. The second is, I think once you are aware of the non-IT equipment that is present in your infrastructure, I think it is you should segregate those two in terms of IT and OT. Think of how people in manufacturing plant and in critical infrastructure talk about IT and OT. Just take it as a simple form of that. The only thing here is that there may or may not be a segregation between the IT and the IoT infrastructure, and they might be part of your IT network itself. So once you get the hang of it, then you can go ahead and create asset management and inventory and asset management policy for both IT. I'm sure everyone already has it for IT. If you do not have it for IT, then you can go ahead and create an asset management policy and security policy for your non IT equipment. So I'm using non-IT equipment and IoT interchangeably here, but when I say non-IT equipment, it could also mean things like your legacy devices, like your printers as well. The next point is that red team is not equivalent to IoT assessment, because red team is limited by the objective, whereas IoT security assessment is limited by the scope, which means that if somebody is performing red teaming on your building, they will have an objective, let's say, to get access to your server room and to deploy a dummy malware in one of, or control one of your servers. Now, whether this means that they have to bypass your access control, physical access control systems, if yes, they will do it. If it is not required, they might not do it. uh, yeah, even if it is required and they do it, they will only do it for part of your infrastructure. Okay. Whereas in IoT security assessment, you have a scope, you have a well-defined scope in terms of all your assessment of all your IoT assets, be it different access control systems from different vendors, different camera systems from different vendors, TVs, Fire sticks, Alexa, conferencing equipment, uh, uh, temperature sensors, whatever you can think of. And once you have that in scope, the security assessment team has to go through assessing the security for each of this, and they'll not be limited by just a specific objective. So the objective here is to make sure that your IoT infrastructure is secure. So once you have that, then you also need to create a patch management plan. Now, patch management plan going forward may not be that difficult, because the upcoming compliance standards and regulations are reinforcing controls for secure and automatic updates. So if manufacturers start to follow that, I think patch management would not be a problem, unless you have a policy where these devices do not get internet access directly or indirectly. The next is that the security team typically needs to be a stakeholder in non-IT equipment procurement. So if there are smart ACs or smart HVAC systems being purchased for your facilities, the security team needs to put the same security requirements that you put for RFPs for IT assets. I think that solves a lot of problems in itself. And finally, you need to have vulnerability reporting information. I cannot stress on this more. This is not only specific to IoT, but typically what happens is when researchers find vulnerabilities in your infrastructure or products, they try to find a security contact. If it's not available, then they send emails to sales, support, engineers, try to talk to people on LinkedIn, and typically they get standard response from customer care saying, thank you for the feedback, we will get back to you within 48 hours. And then after 48 hours, you get, okay, thank you, we've sent the details to the IT department. So then typically they get frustrated and they publish the findings on the internet. Now, you wouldn't want your vulnerabilities published on the internet just because the security teams or the engineering teams did not get the information on time. So having a web page, a simple web page with an email ID that could be a group email ID for security and incident response team, I think can do wonders. You do not have to pay bug bounties. You can have your own policy where you can give certificates or thanks or whatever you want to do. But at least having a centralized information for security reporting will help you in the long run. Now, for the product owners, I think one of the simplest things is that you just look up the IoT security guidelines as well as IoT compliance and regulations. And there are a lot of compliance which are currently under work. So maybe released next year or in the near future. But if you look at these guidelines itself, one of the challenges for IoT is more from the things on the lower level of the technology stack, like as I mentioned, hardware, firmware, radio communication interfaces. And typically on the software side, you have information available and guidelines available. You have OWASP, you have Cloud Security Alliance, you have Null, you have a lot of different communities and non-profit organizations working towards creating, documentation that will help the engineering community. But when it comes to the lower level, there is not much information available, and that is where these guidelines come in handy. If you look at IoT Security Foundation checklist, I think it's a very comprehensive checklist in terms of where does your product fit and what are the things that you need to take care from updates perspective, from the hardware perspective, from the radio communication perspective. Same with the GSMA IoT security guidelines. It is a comprehensive set of documents along with a checklist as well. Now, just because it is GSMA does not mean that it is limited to telecom. It is more or less generic for any kind of IoT product. And then you have IOXT Alliance Pledge, which has 8 pledges, and based on those 8 pledges, they've made profiles for different product types, like speaker profiles, lighting profiles, camera profiles. And once you go through them, you will figure out that eventually a lot of the guidelines are talking about the same thing. Same goes for compliance and regulation. You have ETSI 303645, which is generic for consumer IoT, but talks a great deal of security aspects for any embedded on IoT device. Then you have California IoT Security Bill, and then you have domain specific compliance like IEC ISA 62443 for industrial products, GDPR for privacy, and then there is IEC 80001-2-2 for medical, and then there are a lot of different compliance standards for different domains. The third is including a security process, not just for the software piece or the application piece, but also for the embedded and the hardware piece. So having putting security requirements while designing hardware will help you again in the long run, at least from the product recall perspective. Having DevSecOps implemented not just for the cloud or the web or the mobile code, but also for the firmware itself, and then security testing for the overall product. And obviously, you will change code for or update code, add new features. So the moment you add in code, I think I don't need to stress this, but the moment you add in code, either you are adding there is a chance that you will add a new bug, or there is a chance that there will be a regression and an old bug will become alive. So if you're doing continuous development, you also need a continuous vulnerability management plan. And finally, I think nothing is 100% secure. As you might have seen the wrappers for sanitizers as well, and the COVID vaccine as well. there is nothing as 100% safety and security from anything. But if you follow standard basic infosec guidelines or basic infosec hygiene, I think you can do away with 99.9% of issues with your products or infrastructure. Basic things like not hard coding credentials in the code, whether it is firmware or mobile application or whatever, not having default or guessable passwords, have a secure firmware update mechanism over a secure channel, filter input. So one of the things that is pretty standard way for researchers to find vulnerabilities in black box system is through fuzz testing or giving in malicious input. And typically the thought process is that, hey, this is a custom communication protocol, or this is a radio protocol. How would somebody send a malicious payload? I don't think it is. If you can accept data from a specific interface, then anybody can send any data over that interface. So regardless of what interface it is, you need to have proper filtering mechanism for that input based on what kind of threats you see at the back end. So if it is over a radio communication, then obviously the firmware will be parsing the input at the end. So the threat here could be memory corruption issues. If it is web based, then you need to test for standard things based on what you're doing, cross-site scripting, or if the data is going to a database, then looking for SQL injection. So based on the interface and the context, you need to filter input for specific and known issues. If you need help with that, I think that was one of the challenges that we saw in terms of security testing IoT, and we found it very difficult to perform security testing for different products over time. And that was one of the motivations why I went ahead and I created an open source framework for security testing IoT products. And so the idea was simple, that instead of wasting time writing code, fixing custom code or fixing tools, if we can take that pain away from the engineers, then they can focus on writing the actual business logic of either the attacks or regression or whatever kind of testing they want to perform. So as of now, it has more than 30 different test cases which you can automate within your CI/CD pipeline, or you can use it for testing as well. The link to the source code is there. There is comprehensive documentation available as well. Feel free to use it. If you like it, if you don't like it, please send feedback on why you don't like it, or what are the things that you would like to see in this in the framework itself. All right, and just before I finish, I think I will end with the shameless marketing slide here. We are also coming up with a compliance testing platform, which will cover a security testing from a 360-degree coverage of IoT, be it the radio communication interface, the hardware analysis, the firmware analysis, all from a single dashboard. And we're currently running beta for it. So if you guys are interested for the beta, please shoot me an email as well. So let's get ready for the new frontier. There are a lot of challenges, and let's kick some IoT butt together. And I think over time we will figure out how to go ahead and secure our IoT infrastructure itself. This is a typical cycle that technology follows. The same what happened to the software industry in the 90s is happening to the hardware and automation industry in this decade. So thank you. Stay safe, and I think we will eventually get over this COVID pandemic problem as well. All right, I'm all yours for Q&A.
Thanks, Aseem. Excellent. I mean, I must credit to your credit. I must say that it began in a very storytelling method, and at the beginning, I couldn't believe that we are going to get into complex technology explanation on IoT security. So, you have learned. I mean, this is a great art that you have mastered of storytelling, and it is chiseled, it is polished. Congratulations on that. Great session.
Thank you.
And how you built the whole story from the beginning, that traditional there was a traditional IT, then it graduated to the cloud, then shadow IT happened, and then devices inside people, assets on the cloud that we aren't aware of, then automation through cyber physical system, and then coming on to the core subject of IoT and sensors, and how they created the nightmare for the CISO and security teams, security organizations. Brilliant. So there are certain questions that have been asked by our viewers today. So Karthik, for example, if I can start taking some questions, Karthik is saying that core Internet of Everything security problems I have come upon. I mean, I have faced with my small experience is with communication medium, especially with any radio wave communication. And another part of it is how the microcontroller bootloaders are coded. So can you throw some light on this? Can you highlight these points?
Okay. All right. So as I mentioned, the hardware and the radio are and the sensor. They're the three core attack surface areas which the researchers are focusing now. And I think the primary reason is because of the availability of cheap microcontrollers now. And so let's take it one by one. From the microcontroller perspective, I think it again depends on what kind of microcontroller or microprocessor you go for. Every microcontroller has their own bootloader process, secure boot, but eventually it boils down to what is the objective, or what is the use case of your product, where will your product be deployed, and based on that you will need to take certain decisions in terms of which microcontroller or microprocessor you're going to use. For example, if it is like a smart toothbrush, you really do not have to go ahead and bang your head and say that I need a secure element along with my microcontroller so that I can have my keys protected, so that I make sure that the firmware that the bootloader will load the correct firmware every time, versus a pacemaker, right? Or versus something that would be deployed in a nuclear power plant. So the decision on which particular chip you are going to take will be based on your risk for the product, plus what are you willing to spend on the cost, or cost for that product. The second is again radio, and the challenge here is that as soon as there is a radio protocol which starts to become famous, there are people, hobbyists, and companies who will create tools or chipsets that will use the same communication protocol, so that you can test. Obviously, when you're developing something, you need to be able to test your code as well, right? So that that becomes bit easy from I'm not sure if the question was whether it is difficult for a researcher or whether it is difficult for from a developer perspective. So if it is from the researcher perspective, I would say that pretty much most of the radio communication that you see, there are cheap tools available. All you need to do is just take those chips, or just take those boards and write code on top of it to create your own test cases. So really, they're not difficult from financial perspective, but you need to know what you're doing.
Great. You briefly mentioned about uh, regulatory and compliance framework and IoT specific regulations. I just wanted to ask, in the light of some of the reports that have been published, for example, Symantec 2019 Internet Security Threat Report, which said that the cyber attacks on IoT environment they are tripling every year, and this includes bots or worms that can compromise smart devices such as Linux-based internet routers. And they are also leveraged to commit additional crimes such as, DOS attacks or illegal, illicit mass marketing. So, uh, which agency in India, what kind of regulations are you seeing coming up in this domain? Do you closely also work with agencies like NCIIPC, which mandates the industrial IoT? The firms which are using industrial IoT.
Okay, all right. So from the regulation perspective, I think the the only body that is mandated to create standards is Bureau of Indian Standards. I'm fortunate enough to be part of the IoT security working group at Bureau of Indian Standards, and I must say BIS along with STQC and a lot of volunteers across the private sector are doing a really good job in terms of defining IoT, not just IoT, there are a lot of other security standards as well. So from a standards perspective, the work is going on, yes. And we will soon see standards coming in from BIS for IoT as well as mobile device security and so on. Even from the international standard perspective, I'm also part of ISO's working group for IoT security, and there we're coming up with the 3 standards for IoT security. So definitely, there's a lot of work going on. What we need as of now more is regulations in terms of some authority enforcing these standards on private players. Big companies would follow suit, if they see standards coming in and if they see customers asking for it, they would typically go ahead and say, okay, chalo, let's get ourselves compliant to this ISO standard, this IEC standard. Versus startups, unless it is forced down their throats, they're not going to spend money on compliance, right? Or if the customers say that we are not going to take your products unless you get certified, things are not going to change.
Isn't it the same problem that initially when the cloud players, cloud computing, large cloud computing players confronted in terms of their security? So there were stringent rules applied, and they were supposed to certify their cloud instances with the certain specified certifications. So you think that that kind of regulation has to take place to make things better and make things standardized?
Yes, I mean, if you look at the typical cycle as well, right? When I didn't discuss more about the how the trend of attacks changed from the 90s to now. But it's been the same thing. Like when people discovered web, started writing web applications, then the researchers discovered web-based attacks, and then there were a lot of websites which started to get hacked, and then eventually organizations came up, guidelines came up, people started learning from their mistake to an extent where we still have those vulnerabilities, but they are not to such a large extent. Then the same thing happened with the cloud, with mobile. So it's just history repeating itself with the new technology. And the problem with IoT is that it's not one technology. It's a combination of all old technologies, current technologies, and new technologies. So we need reforms in all the different technologies, not just cloud, not just mobile, not just web. We need it for radio, we need it for hardware, we need it for firmware, and so on. So it is a difficult problem to solve.
No, I understand. So, another very interesting and also dangerous aspect is about the counterfeit devices. I mean, as any market would do, IoT devices are also plenty of IoT devices are there, which are counterfeit devices. Um, Not only do the counterfeit devices and component represent a very significant revenue drain from the rightful owners of the technology, they also have a very significant risk to OEMs and end users of technology. So, is there any mechanism? I mean, this question might sound very naive, but is there any mechanism where the industry is thinking of putting up, whitelisting and blacklisting of IoT devices?
Um, I mean that there are the best that we can do is regulations, and this needs to be an effort more or less from non-profits or alliance where they can talk about so we started this, but we haven't really picked it up again yet, that starting to give star ratings to different products. Like you pick a product and then you say that these are the issues in this products, so this gets 1 star, kind of like your you see in your air conditioners and fridges. But again, I mean, this needs to be a coordinated effort where, and the problem is that these devices, the sheer number is so huge. If you look at just wearables, if you just search on Amazon, Flipkart, AliExpress, there are tons of different companies with similar looking similar looking watches. So how do you go about and rate those all those variables? It's just impossible to do. And counterfeiting is a big challenge for these devices, more from the perspective of backdoors. Now anybody can any company can say, okay, we are a smart router for your home, right? You don't know what's inside the router. They're not dealing, they're not Netgear, you don't know the company, right? And then you have tons of companies like this. Even if you have a Netgear router, refurbished Netgear router somebody is selling, how do you know that there is the firmware is not modified? So those are bigger challenges. I mean, we're trying to solve it for conventional server devices, desktops which are sold. If you look at the process in which they are sold, there's a lot of security aspect to when they come out from the factory till the time they reach the customer. That's not the case with these cheap devices.
So I have a couple of time for a couple of more questions. So two people have asked the same questions. Same question. I have Syed Tasneem. He is from JSW Steel. He wants to know, to be very simple and specific, from where can one start in IoT, OT security? What could be the scope for manufacturing industries? And similar question was from Ravi Kumar, who wants to know, is there any beginners study or beginners guide for IoT security?
Okay, all right. So for freebies, I think if you search on the internet, there are some people who have created GitHub repos where they have listed down various learning material for IoT. If you go to our website pyre2.com, we have an IoT security master series, a set of I think 21 or 23 blogs, and we've just combined that as well. So the best place to start would be those. If you have some money in your pocket, then you can go on our website exploity.io, where we sell a small kit for beginners, where they can tinker around with the hardware and the and radio protocols to get a basic understanding of what are the attacks that we are talking about, like how do you extract memory, how do you look for scan for debug ports on the hardware, and so on and so forth.
Okay, so another question, and I remember you showing a slide saying that I am shamelessly putting up this slide for marketing purpose. Sudhir Dalvi from ICICI Bank is asking a question. Does Exploit or Payatu conduct training on IoT security for beginners? So this is your time to market once again.
Yes, we definitely do. That's my email address. Please send us an email, and yeah, we can take it on from there.
Great. I think I will put a full stop on the queries because you have already showcased your email ID. You've shared your details. It's right up there on the screen for everyone to view. I can't thank you more, Aseem. I always, when I'm interacting with you as a journalist, I learn more. I'm glad that you could take time out for this session, and in the future we will again have an opportunity to talk to you, to have you in our sessions like these. Thank you very much, and I wish you a great weekend ahead.
Thank you so much, Rahul, for having me. I mean, it was a pleasure and an honor to be at uh, this platform, and I'm sure we'll meet again.
Absolutely,
Thank
absolutely.
you.
Thank you, and be safe. Thank you.
Thank you.